A lot of work that we do in this class is going to involve the coordinate plane, so let's do some review of using the coordinate plane. Alright, so the coordinate plane is the xy plane with two coordinate axes like this. Every point in the plane has two coordinates, an x-coordinate and a y-coordinate. To find the x-coordinate, you just sort of squash the point vertically down onto the x-axis and see where it ends up. Right? Maybe this x-coordinate is 3. And then to find the y-coordinate of the point, you squash the point sideways onto the y-axis and see where it ends up. Looks like that one is at 2. And so the coordinates for this point are, you write the x-coordinate first, so 3, and the y-coordinate second, so that's 2. All right. Now on the x-axis, when you get to the left like this, you get negative x values. And on the y-axis, when you get down below the x-axis, you get negative y values. So every point in the coordinate plane has a unique pair of coordinates. Notice the coordinate axes break the plane up into 4 chunks. Each chunk is called a quadrant, and they're numbered. So this quadrant in the upper right, it's called quadrant 1. And this is where all the x-coordinates are positive and the y-coordinates are always also positive. In the upper left, this is called quadrant 2. And in this quadrant, all the x-coordinates are negative and the y-coordinates are positive. In the lower left, that's quadrant 3. And that's where x-coordinates are negative and y-coordinates are also negative. And then finally in the lower right, that's quadrant 4. And that's where x-coordinates are positive and y-coordinates are negative. Okay, so when we work in the coordinate plane, all of our points will have pairs of coordinates, and so a lot of the calculations that we do will involve the coordinates for the points that we're working with. Let's look at a couple examples of the kinds of calculations we can do using coordinates. There are a couple main examples. So our first example of the type of calculation that we can do using coordinates is, let's find the midpoint between these 2 points, 1, -4, and -3, 10. All right, well, if we plotted these points, let's see, 1, -4, so that would be 1 in the x direction and -4 in the y direction, so something like here. And -3, 10, so that's -3 in the x direction and 10 in the y direction. That would be up here. And the midpoint is the point halfway between, so if we just sort of sketch the line segment between those 2 points, it looks like the midpoint is somewhere about right there. All right. Well, in the x direction, the midpoint is just halfway between the x coordinates of the 2 points we started with. And in the y direction, the midpoint is, again, halfway between the y coordinates of the 2 points we started with. So it seems like the coordinates of the midpoints are just the averages of the coordinates of the points we started with. And it turns out that that is true. So the midpoint, to find the midpoint, we'll write the coordinates of the midpoint. And the x-coordinate of the midpoint, we'll just take the x-coordinates of our original points and find the average. So 1 plus the other x-coordinate is -3, and then over 2 to get an average. And then for the y-coordinate of the midpoint, we'll just take the average of the y-coordinates of the original points. So that's -4 for the first one, plus 10, and then divided by 2 to get an average. So the midpoint is, let's see, 1 plus -3 is -2. -2 over 2 is -1. And then -4 plus 10 is 6, divided by 2 is 3. So the midpoint is -1, 3. And that looks about right on this picture. Not perfect, but then the picture isn't perfect either. I would trust the calculation before the picture. All right, so another example of the sorts of things we can calculate using coordinates is the following. So if we have these 2 points, 1, 2, and our second point is 4, 6. Besides the midpoint, another thing we can calculate is, let's find the distance between the 2 points. All right. So again, let's just draw a quick picture. 1, 2 maybe is something like this. 4, 6 is something like this. And so we want the distance between them. But if you look at these 2 points, they have a distance sort of horizontally like that, and a distance vertically like that. And vertical distances are perpendicular to horizontal distances, so this blue side and the green side are actually perpendicular. And that means that all of these sides make a right triangle. And one thing that we know about right triangles is the Pythagorean theorem. So if we write the Pythagorean theorem, we could call this bottom side delta x, the difference in x coordinates. The right-hand side we could call delta y, that's the difference in y coordinates. And then the hypotenuse, we could call that maybe just d for distance. Then the Pythagorean theorem says that d squared is the change in x squared plus the change in y squared. And remember, we were after the distance between the 2 points, so now we can just take square roots to find the distance. So the distance is the square root of the change in x squared plus the change in y squared. Now we have to avoid the temptation to distribute the square root because remember, square roots don't distribute. All right, so this is the different distance formula. Let's use this formula to find the distance between our 2 points. So the distance is the square root of, now remember, delta x represents the horizontal distance between the points. And to find the horizontal distance between the points, we can just take these x coordinates and subtract them. So 4 minus 1 plus, now we need to find the difference in y coordinates squared. And the difference in y coordinates is just going to be the difference between 6 and 2, so 6 minus 2. All right, now our formula is all set up. We can find the distance just by doing all of this arithmetic. So this is the square root of 4 minus 1 is 3 squared plus 6 minus 2 is 4 squared. Let's see, square root of 3 squared is 9, 4 squared is 16. So square root of 9 plus 16 is 25. And the square root of 25, oh, that's a nice one. It turns out to be 5. So these 2 points are exactly 5 units apart. All right, so there are a couple things we can do in the coordinate plane. There are a couple more ideas in the coordinate plane that we will use extensively. The first one is the graph of an equation. So first let me just write an equation to have one as an example. Let's try y equals x squared plus 1. All right, so the graph of an equation is all points. And remember, any point has an x coordinate and a y coordinate, so let's call this point x comma y. All points that make the equation true when you plug the point into the equation, when put into the equation. Okay, so for this particular equation, let's try some points. How about 0, 0? If you put 0, 0 into this equation, you get 0 equals 0 plus 1. But that's false. So the point 0, 0, we will not put a dot there. All right, let's try a different point. How about the point 1, 0? That would be right here. So put those coordinates into the equation. 1 equals 0 plus 1. Well, that one is true. And so this point, we're going to put a dot on this point. Right there. Okay, and then we'll move on to another point. How about 1, 1? 1 equals 1 squared plus 1. That's false. So do not put a dot on 1, 1. Well, if you continue doing this process forever, what you'll find is that all of the points that satisfy this equation actually organize themselves along a curve. And this one you're probably familiar with, y equals x squared plus 1. That's a parabola, but it's moved up 1. And so it looks something like this. Okay? And for any point on this graph, it satisfies this equation. So that's the key thing about a graph. A point on the graph satisfies the equation, and if a point satisfies the equation, then it's on the graph. Okay. Now, since graphs are geometric objects, they have geometric properties. And there are a few geometric properties that I want to talk about. Let's talk about intercepts. An intercept is, remember, an intercept is where the graph crosses one of the coordinate axes. And since there are two coordinate axes, there are two types of intercepts. There's an x-intercept and a y-intercept. An x-intercept is where the graph crosses the x-axis. Okay? But the x-axis, that's where y is 0. So the x-intercept, that's where y is 0. And the y-intercept is where the graph crosses the y-axis. But the y-axis is the line x equals 0. And so the y-intercepts are where x is 0. Now this seems backwards, but this is how it works out, because the x-axis is the line y equals 0, and the y-axis is the line x equals 0. So this looks backwards, but it's actually correct. Okay, so this description of the axes actually gives us a way to find the axes for any particular equation. So for example, let's find the intercepts for this equation. Y equals x plus 1 over 2x minus 3. Okay, well, intercepts come in two varieties, x-intercepts and y-intercepts. So let's find the y-intercepts first, just because it's easier, actually. So remember the y-intercepts, that's where x equals 0. But if we have a point on the graph, that means it satisfies the equation. And if we have an intercept, that means x has to be equal 0. So we have a point that makes the equation true, and also x is 0. Well, that means we can take x equals 0 and put it into the equation. We get y equals 0 plus 1 over 2 times 0 minus 3. And that's minus 1/3. So the y-intercept for this graph is, it's a point. The x-coordinate of the point is 0, and the y-coordinate of the point we just found is minus 1/3. All right, so that's for y-intercepts. Now let's find the any x-intercepts for this graph. And remember, an x-intercept, that's where y is 0. But just like we did for the y-intercepts, Right, now we have two equations. We have y is 0, and we have the original equation whose graph we're talking about. So we can combine these two equations. In other words, we can put in y equals 0 into this equation, and we get 0 equals x plus 1 over 2x minus 3. And now we need to solve this equation to find x. Well, this equation is a rational equation, so we'll have to remember how to solve rational equations. What we'll do to solve this equation is clear denominators. So multiply both sides by 2x minus 3. On the left-hand side, when you multiply by 2x minus 3, well, it's 0 times 2x minus 3, and that's 0. On the right-hand side, when you multiply by 2x minus 3, these just cancel. And we're left with x plus 1. And that means that x is minus 1. And so now we've found the x-intercept of our graph. It is the x-coordinate is the x-coordinate we just found, which is minus 1. And the y-coordinate of the x-intercept is 0. And so the x-intercept is the point minus 1 comma 0. And that's how you can find intercepts of a graph.